Hi, I'm Emily, and today I'm going to be combining my passions for beach volleyball and science to teach you how physics applies to serving a volleyball.
There are two main types of serves, a topspin and a float serve, and I'm going to teach you how each of them are affected by the Bernoulli Principle in laminar flow. To begin, we are going to explore the Bernoulli Principle, which states that the speed of a fluid determines the amount of pressure that a fluid can exert. Bernoulli's principle is the same idea that creates lift on an airplane wing. If the air flowing past the top surface of an airplane wing is moving faster than the air flowing past the bottom surface, Bernoulli's principle implies that the pressure on the surfaces of the wing will be lower above than below.
Bernoulli's principle applies when a player topspin serves a volleyball. When they make contact with the ball, they're going to snap their wrist over the ball like this, as it causes the ball to have topspin, so it spins forward through the air.
A topspin serve looks like this. As the ball undergoes topspin, it causes the velocity of the air around the top half of the ball to be lower than the velocity of the air around the bottom half. Since the air is moving faster around the top half of the ball than the air is around the bottom half of the ball, the pressure is greater on the top of the ball, and this causes a net downward force to act on the ball.
Another very common type of serve is called a float serve. When a player performs a float serve, they make contact with the ball with a stiff hand and a flat wrist to ensure that there is no spin on the ball as it travels over the net. This lack of spin contributes to something called flow. When a ball floats through the air, it moves around like this, and it makes it incredibly hard to pass when you're on the other side.
A float serve looks like this.
The physics of a topspin serve makes its path of flight very, very predictable because the lift is always created on the same side of the ball. A ball with no spin is subject to unpredictable interactions between drag and lift.
Next, we're going to discuss laminar flow, which is defined as airflow in which the entire body of air is uniform in both velocity and direction. Eventually, there comes a speed where the boundary layers are no longer able to hold together and they break away along the trailing edge of the ball. This state is called turbulent flow, and the airflow around the ball becomes varied in magnitude and direction.
According to Bernoulli's principle, the varying speeds in airflow all around the ball are going to create differences in pressure. Differences in pressure can create lift in any single direction that is perpendicular to the ball's path of flight because the ball is radially symmetrical.
Physicists have combined many of the factors that contribute to this change from laminar to turbulent flow into a single figure that they call the Reynolds number, the ratio of inertial forces to viscous forces that determine whether flow is laminar or turbulent.
Two of the main factors that are contributing to this change from laminar to turbulent flow are the speed at which the ball is served and the fact that air has a very low viscosity. In summary, the turbulent airflow that is created around the ball, combined with the possibility of lift being created in any direction, are going to contribute to the unpredictability of a float serve, whereas a topspin serve is going to have a very predictable path of flight because the lift is always on the same side. Thanks for watching.